Cable-stayed bridges have a truly unique aesthetic and design, combining elements from more common beam and concrete arch bridges, as well as design elements from suspension bridges. The cable-stayed bridge design has been known since the 16th century and has been widely used since the 19th century. Famous examples of the cable-stayed bridge design include the Brooklyn Bridge, which was opened in 1883. Modern examples of this design have a streamlined, futuristic aesthetic using no steel truss superstructure. The simplest possible design for a bridge would be a decking surface placed across a span. A span is simply the gap that the bridge needs to cover. However, across larger gaps, the force of gravity would cause just such a simple bridge to collapse. The vertical towers, such as the one used in the bridge here, are much less affected by gravity. Steel cables are attached to these vertical towers, which bear the load of the decking surface that is transferred into the towers by the cables. The cables support the decking, and in turn the towers support the load in the cables. In general, cable-stayed bridges are comprised of a few common materials. As with most bridge designs, the decking surface is made of reinforced concrete. The towers are made of either steel or concrete. Concrete, as a material, is best suited for uses in which it will be placed under compressive forces, such as those exerted on it by the cables attached to the tower in a cable-stayed bridge. The cables are made of steel, which performs best under tension forces. Each of the cables in a cable-stayed bridge is under an extreme amount of tension, as the cables are used to support the weight of the bridge decking. In many cases, cable-stayed bridges have a different footprint than more traditional arch or truss bridges do. As shown here, cable-stayed bridges can be used over intermediate to longer spans without the use of large concrete pylons placed under the decking for support. Rather, the cables support the decking of the bridge. This allows for less disruption of the flow of water or boat traffic underneath the bridge surface. By contrast, for similar spans, a more traditional truss-style bridge requires large pylons spaced periodically across the span in order to support the decking surface of the bridge. This creates a disruption in the flow of water and boat traffic going under the bridge. In general, cable-stayed bridges tend to be more cost-effective for longer spans, but less cost-effective for shorter spans, where the cost of the cabling reduces the design's economic feasibility.